Alright, welcome back to your favorite intermediate algebra class. Good to see you. Today we're going to talk about solving absolute value equations and inequalities. So that's one of our objectives, as well as to use some of those absolute values and some application here. So the absolute value of a real number, if you remember when you were introduced to that, is by definition the distance the number is from 0. So for example, the absolute value of -7 is 7 because that distance, here's your -7, that distance there is 7, right? Well, you also have an algebraic definition. So the algebraic definition for the absolute value is the absolute value of x is x whenever x is greater than or equal to 0, and it's the opposite of x whenever x is less than 0. Okay, so for example, let's do the absolute value of -7 again. So you notice that my x is -7, right? Well, if -7 is x, I say, well, which one of these am I going to use? Am I going to use the absolute value of x as x, the top one there, or the opposite of x, that -x there? I say, well, I got to use the bottom here. This is because -7 is less than 0. So I got to use this part of the definition. So it is negative and then, or the opposite of the x value, and the x value is -7. So it ends up being, of course, a negative times a negative, or the opposite of a -7 is 7, if you will. Okay? If you're taking the absolute value of 6 now, the absolute value of 6, well, this time x is 6. You say, well, 6 is greater than or equal to 0, so it's just 6. So the absolute value of 6 is 6. It's just 6, right? The absolute value of x is x whenever x is greater than or equal to 0. Okay? So you want to recall that definition when you're solving some equations, because here, let me write it one more time. The absolute value of x is x whenever x is greater than or equal to 0, or the opposite of x whenever x is less than 0. So let's say we have, instead of just the absolute value of x, let's say we have the absolute value of 2x plus 3. Well, following this definition, it would be 2x plus 3 whenever that 2x plus 3 is greater than or equal to 0, or it's the opposite of 2x plus 3 whenever 2x plus 3 is less than 0. Okay, you see how I'm just following that definition there, the algebraic definition. Now let's do, so you have these two cases. You have the absolute value of 2x plus 3 is that case, or it could be that case depending on the domain. Okay, so let's look here. How does this apply when solving an absolute value equation? Well, you say, oh, I got two cases, just like I was introduced to in Algebra 1. I have the straight up case, 4x plus 2 could be 6, okay? Because remember, the 4x plus 2, that could be 4x plus 2 whenever 4x plus 2 is greater than or equal to 0, or it could be the opposite of 4x plus 2 whenever that 4x plus 2 is less than 0, okay? So my case 1 is that one right there, that 4x plus 2. My case 2 is going to be, well, it's the opposite of 4x plus 2. And then I just bring along the equals 6, okay, because we're solving this as an equation, right? We're just finding the two possibilities. Okay, so 4x equals 4, divide by 4 both sides. Let's say x could be 1, that's one of my answers. Or, now I go ahead and distribute it over here, solve it, divide, whoops, that's 8, hee hee, divide by that -4, x could be -2. So it's x equals 1, or you could have x being -2. Both of those, if you plug them in, are going to work out and give you a right solution. In fact, we'll check this one. Let's check x being 1. The absolute value of 4 times 1 plus 2 equals 6. 4 times 1 is 4. 4 plus 2 is 6. Is the absolute value of 6 really 6? You say sure. Let's check the other one. X being -2 now, so we're plugging this into the original. 4 times -2 plus 2 equals 6. Well, that's -8 plus 2. What's the absolute value of negative 6? Is that really 6? You bet it is. The absolute value of negative 6 is 6. Okay, so both of those are solutions. Let's do another one. Absolute value of 5x minus 2 equals 3. So you got your case 1. Just drop the absolute value, right? So we're just applying the definition of the absolute value. Second case, the opposite of 5x minus 2 equals 3. And now we just solve the 2. 5x equals 5. Solve that. Looks like we got x being 1 again. Distribute that. Subtract 2. Divide by negative 5. Looks like we got that. Okay. Alright, so that's solving absolute value equations. Now, how would you, what if you have a transformation where you have an inequality? Okay. So if you have the absolute value of ax plus b is less than c, what you're going to have is a compound inequality, and specifically an and compound inequality. Okay, so that's going to be an and compound inequality, and that's where your c is positive. Okay, and if you have something where the absolute value of ax plus b is greater than c, again c is positive, you're going to have an or compound inequality. Okay. And so let's take a look at how this works here. Okay, so let's solve this inequality, which is of the form ax plus b is less than c. So again, we're going to have the two cases, okay? But you notice that it's less than a positive number. So I'm instantly thinking, well, this is an and compound inequality. You'll probably see it when I do the two cases here. So case 1, drop the absolute value, and then and we got to do the case 2 here. The opposite of 2x minus 3 is less than 3. Okay, we go ahead and we solve this just like we would normally in inequality. Divide by 2, x is less than 3. And subtract 3 both sides, 0. And still, when I divide by a negative, don't forget you got to change that, right? So x is less than 3 and it's greater than 0. So what does this thing look like? Well, if x is less than 3, x is less than 3, strictly less than 3, right? So not including 3, and x is greater than 0, greater than 0. You see how those cross right there? And remember, this is an and inequality, so the solutions have to satisfy both of those inequalities. It's the intersection of those two inequalities. I say, well, that's the only place where they intersect. So my actual answer is between 0 and 3 graphically. Okay, that's my graphical solution. So now I got to put these two together. Okay, so I say, well, x is less than 3 and x is greater than 0, but I'm not, I got to flip that around to plug it in, right? So I put that in right here. So it's between 0 and 3, right? And actually the graph just shows it to you anyways. You can just, write this solution. You say, well, x is less than 3, that part, and it's also greater than 0 on that part, right? Smallest number on the left, biggest number on the right. Okay? All right, let's do another one like that. Absolute value 3x plus 4 is less than 2. So again, you're thinking and. This is an and. We are less than a positive number here. We have absolute values less than a positive number. So case 1, drop the absolute value. And case 2, the opposite of whatever's in that absolute value. It's less than 2. Solve it. Subtract 4 both sides. Divide by 3. And distribute. Add 4. Divide by negative 3. Don't forget you divided both sides by a negative number. You got to switch that, right? So x is less than negative 2/3 and greater than negative 2. So here's -1, here's -2, right? That's my graph. So negative, make these a little bigger here. Okay, so -1/3, -2/3. There's our -2/3. X is less than -2/3, and X is greater than -2. Again, this is an and inequality, so I'm looking for the intersection. Looks like the intersection would be right there. So there's my solution, graphical solution. Now let's put these two together. We are less than -2/3, that's my bigger number, and we are greater than the -2, right? Okay, so that's and inequalities. Let's take a look at or inequalities. Okay, so you notice we have greater than, actually in this case greater than or equal to, treated that way, so it's an or, okay? We're greater than a negative, greater than a positive number. So we still have the two cases. Case 1, 2x plus 7 greater than or equal to 3. Or, this time, let's see case 2, 2x plus 7, I'm sorry, the opposite of 2x plus 7 greater than or equal to 3. Okay, solve this. Divide by 2. Solve this. Add 7. Divide by -2. Make sure you have an or between them in this case. And that's our answer. Oops. Let me do that over here. So -2 we're greater than or equal to, and then we're less than or equal to that -5, right? There's our graph. Sorry, it's in the way there, but that's our graph here. Okay. All right, that's an or. Let's try one more. Or you guys can pause this and try this before I do it. Greater than or equal to, again, is an or situation, or a greater than. So or. Okay, add 3. Divide by 2. Subtract 3. Divide by -2. And this is or. Greater than or equal to 4. Less than or equal to the -1. Okay. All right. Make sure you guys bring your questions to class. See you then.